Hello dear students, welcome to mathematics class. So in this class let us discuss some more examples on Cauchy's integral formula and Cauchy's integral formula for derivatives. So the first example of today's class is evaluate integration over c e power 2z divided by z plus 1 whole square into z minus 2 dz over the circle C such that mod z equal to 3. So here in the given integral f of z is e power 2z and the denominator is of the form z plus a whole power n and as well as z minus a. So to apply the Cauchy's integral formula for derivatives, the denominator must contain only one term, but here it is the product of two terms. So therefore let us split the denominator such that there should be only one term in the denominator. So by using the partial fraction, that 1 divided by z plus 1 whole square into z minus 2 can be written as a divided by z plus 1 plus b divided by z plus 1 whole square plus c divided by z minus 2. So here after solving that partial fraction, we got a equal to minus 1 by 9, b equal to minus 1 by 3 and c equal to 1 by 9. So now substitute all the values of a, b and c here, then this equation becomes minus 1 divided by 9 into z plus 1 minus 1 by 3 into z plus 1 whole square plus 1 by 9 into z minus 2. So just we have substituted the values of a, b and c. So now here f of z equal to e power 2z. So now the circle mod z equal to 3 is given. So therefore here the center of the circle is 0 comma 0 and the radius is 3, right? So here mod z equal to 3, it implies, let us denote the center as z naught, which is equal to 0 comma 0 and the radius is 3. So now consider one by one integrals. So here integration over c e power 2z z plus 1 whole square into z minus 2 dz can be written as integration over c of the first function, that is 1 by 9 into z plus 1 minus 1 by 3 into z plus 1 whole square plus 1 by 9 into z minus 2. So let us evaluate all the three integrals separately. So now consider integration over c 1 divided by z plus 1, here minus 1 by 9, let us take that outside since it is the constant, into e power z. So here f of z is e power 2z. So here also we will get e power 2z, e power 2z, e power 2z, since the numerator is e power 2z. So for each the function f of z will be e power 2z. Now it implies that here in denominator we have z plus 1, it implies that a is equal to minus 1, f of z equal to e power 2z, right? So here the power of this one is equal to 1. Whenever the power of z minus a is equal to 1, then we need to use the Cauchy's integral formula, that is integration over c f of z divided by z minus a dz equal to 2 pi I f of a. So therefore it implies that minus 1 by 9 into integration over c e power 2z divided by z plus 1 dz equal to minus 1 by 9 constant as it is, then value of this integral is 2 pi I f of a, where a is equal to minus 1. So we know that f of z equal to e power 2z, then f of minus 1 becomes z equal to minus 1. We need to substitute, that is minus 1 by 9 2 pi I e power minus 2. This implies that it is equal to minus 2 pi I divided by 9e square. That is the value of the first integral, that is integration over c e power 2z divided by z plus 1 dz. So, this is equal to minus 2 pi I divided by 9e square. Then the second integral is minus 1 by 3 integration over c e power 2z divided by z plus 1 whole square dz, right. So, here again a is equal to minus 1 f of z equal to e power 2z. Here we are going to find the value of n, because it is of the form f of z divided by z minus a whole power n plus 1. So, therefore, whenever the power of z minus a is greater than 1, then we are going to use the Cauchy's integral formula for derivatives. So, here the power of z plus 1 is 2, means n plus 1 equal to 2, it implies that n equal to 1. So, therefore, here minus 1 by 3 integration over c e power 2z divided by z plus 1 whole square dz. Now, this implies that minus 1 by 3 as it is, this is 2 pi I f dash of minus 1, f dash of minus 1. So, here we know that f of z equal to e power 2z, this implies that f dash of z, so f dash of z equal to 2 into e power 2z, then it implies f dash of minus 1 equal to 2 into e power minus 2. So, that is the value of f dash of minus 1. So, therefore, this is equal to minus 1 by 3 2 pi I into 2 e power minus 2. So, therefore, now this becomes minus 4 pi I divided by 3 e square. So, it is the value of the second integral, that is minus 1 by 3 2 into 2, that is 4 pi I e power minus 2 means 1 by e square. Then, so let us move towards the third integral. So, that is integration over c e power 2z divided by 9 into z minus 2. So, here 1 by 9 integration over c e power 2z divided by z minus 2 dz. So, now this implies here a is equal to 2 and f of z equal to e power 2z, because here it is z minus 2. So, it is in the standard form z minus a, hence a is equal to 2, and since the power of this z minus a is equal to 1, we are going to use the Cauchy's integral formula. So, therefore, 1 by 9 integration over c e power 2z divided by z minus 2 dz is equal to 1 by 9 2 pi I f of a. So, a is equal to 2, hence that becomes f of 2, then 1 by 9 2 pi I f of z is e power 2z. So, f of 2 means e power 4. So, therefore, it is equal to 2 pi I e power 4 whole divided by 9. So, now here we got the values for all the three integrals. Then, so let us consider this as equation number 1, that is the sum of three integrals, that is considered as equation number 1. Now, go on substituting the values of each integral. So, therefore, here integration over c e power 2z divided by z plus 1 whole square into z minus 2 dz is equal to the value of the first integral, that is minus 2 pi I divided by 9 e square, minus 2 pi I divided by 9 e square. Then here this minus we have already considered, so therefore it becomes plus, and its value is minus 4 pi I divided by 3 e square plus the value of the last one is 2 pi I e power 4 divided by 9. So therefore this is the value of the given integral, that is integration over c e power 2z divided by z plus 1 whole square into z minus 2 dz. Next example, integration over c 3z minus 1 divided by z cube minus z dz over the circle C such that mod z equal to 2. So here also the denominator is not in the standard form. So therefore let us bring the denominator to the standard form. So for that, split the denominator. Now the common thing is z, then remaining z square minus 1, which is equal to z plus 1 into z minus 1. So now consider 1 divided by z into z minus 1 into z plus 1. Now the factors of this one is a by z, b by z minus 1, c by z plus 1. Then by using the partial fraction, we can find the values of a, b and c. So here a equal to minus 1, b equal to 1 by 2, c equal to 1 by 2. Then this becomes minus 1 by z because a equal to minus 1, and 1 by 2 times z minus 1 since b is 1 by 2 and c is also 1 by 2. So therefore 1 divided by 2 into z plus 1. Now integration over c 3z minus 1 divided by z cube minus z dz, that is the given integral. So that can be written as integration over c minus 1 by z dz plus integration over c 1 by 2 into z minus 1, 1 by 2 into z plus 1 dz. So here in the numerator we have considered 1, but here since the function is 3z minus 1, so therefore numerator of each integral should be is equal to 3z minus 1, which is f of z. So therefore let us rearrange that. This is integration over c 3z minus 1 divided by z dz. So put this negative sign outside the integral sign plus integration over c 3z minus 1 divided by 2 times z minus 1 dz, integration over c 3z minus 1 divided by 2 into z plus 1 dz. Then this is equal to. So here instead of calculating each integral separately, so here only we can apply the Cauchy's integral formula directly. So here this minus as it is. Now it is of the form f of z divided by z minus c. So its value is equal to what? 2 pi I f of a, right? So here 2 pi I f of a is equal to 0 because it is z minus 0 plus here 1 by 2 is constant. Let us write that one as it is. Then the integral becomes 3z minus 1 divided by z minus 1, which is of the form f of z divided by z minus a. Hence its value is also 2 pi I f of a is plus 1 plus here also 1 by 2 is constant, then it's 2 pi I f of minus 1 because it is z plus 1, hence a will become minus 1, so hence that is f of minus 1. So now we will find f of 0, f of 1, f of minus 1. So here f of z equal to what? 3z minus 1, right? Now f of 0 becomes 3 into 0 minus 1, which is equal to minus 1, and f of 1, that is 3 into 1 minus 1, which is equal to 3 minus 1, that is 2, right? And f of minus 1, that is 3 into minus 1 minus 1, which is equal to minus 4. So now we got the values of f of 0, f of 1, f of minus 1. Let us substitute all these three values in this equation. Then integration over c 3z minus 1 divided by z cube minus z dz is equal to minus 2 pi I into minus 1, because f of 0 is minus 1. And here we can cancel out this 2 and 2, remaining plus pi I into f of 1 is 2 plus 2 get cancelled, then pi I into f of minus 1 is minus 4. So therefore minus into minus becomes plus 2 pi I plus 2 pi I minus 4 pi I. So its total value is 0. So therefore this is the value of the given integral. So here we have not calculated each integral separately. So here we have applied that Cauchy's integral formula directly. So that will become very easy to apply. Next example, integration over c z plus 4 divided by z square plus 2z plus 5 dz over the circle c such that mod of z plus 1 minus I is equal to 2. So here the denominator of the given integral is a quadratic equation. So now we need to find the factors of that. So here by using the formula that z equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So after applying that formula, here we got minus 2 plus or minus I into here 4 minus 20, that is minus 16. That minus 16 can be written as I into root 16, that is 4. Then after simplifying, that becomes minus 1 plus or minus 2i. So therefore the roots of this equation are minus 1 plus 2i, minus 1 minus 2i. So minus 1 plus 2 minus 1, here this becomes minus 2, minus 1 comma minus 2, and the given circle is mod of z plus 1 minus I is equal to 2. The standard equation is mod of z minus a is equal to r, right? So here let us write this in the standard form, that is z minus a. So now the coefficients of the center are minus 1 comma plus 1, because the real part is minus 1 and the imaginary part is plus 1. So therefore that z naught becomes minus 1 comma 1 and radius is equal to 2. Now here, since the center of the given circle is not 0 comma 0, if it is 0 comma 0, then no need to find the distance between the point and the center of the circle. But here it is other than 0 comma 0, then we need to find the distance between z0 and z1 z2, right? So now by using the distance formula, so let us find z0 z1, that is square root of minus 1 of minus 1, that is 0 plus 1. So here the distance formula, we know that square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? So by using this formula we can find the distance z0 z1 and z0 z2. So we got z0 z1 as square root of 1, which is less than 2. Whenever the distance is less than the radius of the given circle, then it implies that the point lies inside the circle, and if it is greater than the radius, then the point lies outside the circle. Now z0 z1 is less than 2 and z0 z2 becomes 3, which is greater than 2, means the point z2 lies outside the circle and z1 lies out. Sorry, here this is inside the circle. Now here when we know that whenever the point lies outside the circle, then its or the value of the integral at that point is 0. So therefore here we are not going to find the value of that integral at that point. So therefore here just include that factor in the function f of z. So here by using these two we can find the factors, right? So these two are the roots, and factors means z is equal to this one means z minus of this value equal to 0, that is z plus 1 minus 2i, this is one factor, and z plus 1 plus 2i, this is the another factor. Means these two are the factors of this quadratic equation. Among these two, that is z2 is equal to what? Minus 1 minus 2i, means this factor lies outside the circle. Then include this factor in f of z. So usually we are considering f of z as z plus 4, but here whenever the point lies outside the circle, the corresponding part of that denominator can be considered as f of z. It is only when the point lies outside the circle. Now here z plus 4 divided by z plus 1 plus 2i, that second factor, is the factor corresponding to the point which lies outside the circle. Hence we can consider that as f of z. So f of z equal to z plus 4 divided by z plus 1 plus 2i, and the point minus 1 plus 2i lies inside the circle, then we can find the value of the integral at that point. So therefore we are not including that in f of z. So therefore now integration over c z plus 4 divided by z square plus 2z plus 5 dz, this can be written as integration over c z plus 4 divided by, now write the factors of this quadratic equation. There z plus 1 minus 2i into z plus 1 plus 2i, and now we know that f of z, this part is called as f of z because this denominator is included in f of z. Then this is equal to integration over c f of z divided by z plus 1 minus 2y dz. So here this is the f of z. Then the corresponding value of a. So a is equal to what here? So we know that f of z equal to z plus 4 divided by this z plus 1 plus 2y, and a is equal to z minus a. A is minus 1 plus 2y because that point only lies inside the circle. Then integration over c z plus 4 divided by that z square plus 2z plus 5 dz is equal to 2 pi I f of a, right, and a is equal to what? 2 pi I f of minus 1 plus 2i, since it is a complex variable. And now substitute that value in f of z. Here we have f of z equal to z plus 4 divided by z plus 1 plus 2i. So therefore 2 pi I into minus 1 plus 2i plus 4 divided by minus 1 plus 2i plus 1 plus 2i, because z equal to minus 1 plus 2i, that we have substituted. Then here this is 2 pi I into minus 1 plus 4, that is plus 3. So 3 plus 2i divided by plus 1 minus 1 get cancelled, that becomes 4i. So I and I get cancelled, 2 ones are 2 twos are. Then it is pi by 2 into 3 plus 2i is the value of the integral. So here whenever the point lies outside the circle, we are not going to find the value of the integral at those points. So therefore we are not finding means those points must be included in f of z. Remember that point. that is only when the the point lies outside the given circle. Next problem, integration over c z divided by 9 minus z square into z plus I dz over the circle C such that mod z equal to 2. So, for the given circle, center is 0, 0 and the radius is equal to 2. Now, let us factorize the denominator to get the standard form. So, here 1 divided by 9 minus z square into z plus I, that 9 minus z square is equal to what? 3 minus z into 3 plus z into that z plus I as it is. Now, here we have not applied the partial fraction to separate the denominators, because look at the points 3 minus z, 3 plus z and z plus I. Since the center of the circle is 0, 0, then by looking at the magnitude of the A, means by the value of A, we can say that whether it lies inside or outside the circle. So, here for the factor 3 minus z, so here 3 minus z is there. So, this can be written as minus of z minus 3, right. Then the value of A becomes 3, and for the term factor 3 plus z, that becomes A is equal to minus 3. So, for those two terms we got the point A equal to 3 and minus 3. So, here the radius is what? 2 units. It is mod z, means z equal to plus or minus 2. So, here that 3 and minus 3 lies outside the circle mod z equal to 2. So, here whenever the points lies outside the circle, then the corresponding factors to those points can be included in f of z. So, here these two factors, that 3 minus z and 3 plus z, for these two factors the point lies outside the circle, then those two factors can be considered as f of z. So, therefore, here now consider f of z equal to the numerator z divided by 3 minus z into 3 plus z, which is equal to z by 9 minus z square, right. Then here integration over c z divided by 9 minus z square into z plus I, which is the given integral, that can be considered as integration over c f of z divided by z plus I. So, here value of A is equal to what? Minus I, since it is in the standard form z minus A. Instead of minus here it is plus, means the point is negative, that is minus I. Then the coordinates of this are 0, minus 1. Here we got minus 1, which is less than 2. So, therefore, the point lies inside, hence we can evaluate the value of the integral. So, now by using Cauchy's integral formula, that is 2 pi I into f of A is equal to what? Minus I, right. Then it is 2 pi I f of z equal to what? Z divided by 9 minus z square, means minus I divided by 9 minus I square, z equal to minus I. Then it is equal to here I into I square, that is minus 2 pi I square divided by 9. The I square value is minus 1, so already minus is there, so that becomes plus 1, and here I square is minus 1, minus of minus becomes plus, then is 2 pi divided by 10, which is equal to pi divided by 5. That is the value of the given integral. So, means if you want to solve this by usual method, that is a divided by 3 minus z, b by 3 plus z, then c by z minus z plus I. Then you have to find the values of a, b and c, then find the value of the integral separately. Then after finding the value of integrals, substitute those in the equation, then you will get the required answer. But that is time consuming, because unnecessarily you have to find the a, b, c value. So here already we know that these 2 points are outside the circle. Whenever the points outside the circle, then merge those factors. You are going to merge the factors for which the points lies outside the circle with f of z. Along with the numerator, we are going to merge the denominator. That denominators must be the points for which the points which are lies outside the given circle. Next example, integration over c z by z square plus 1 into z square minus 9 dz over the circle z minus 2 is equal to 2. So now consider the denominator z square plus 1 into z square minus 9. So z square plus 1 can be written as z plus I into z minus I, and z square minus 9 is equal to z minus 3 into z plus 3. So here for the first factor, the value of the point is, so instead of considering a, we are considering z1, z2, z3, z4. So z1 equal to minus I, its coordinates are 0, minus 1, and z2 equal to plus I, 0, 1, z3 equal to 3, 0, z4 equal to minus 3, that is minus 3, 0. And the given circle is mod z minus 2 equal to 2, here center. So let us denote that as z0, which is equal to 2, 0, and the radius is 2 units. So by using the distance formula, find all the distances z0, z1, z0, z2, z0, z3, z0, z4. So the first value is root 5, which is greater than 2, then again root 5 greater than 2, root 1 less than 2, and 5 greater than 2. So among these 4 points, only one point is giving the distance which is less than 2. It means that the only point lies inside the circle is z3, that z3 equal to what? 3, 0. Then remaining 3 points, that minus I, plus I, and minus 3, all these 4 points lies outside the circle. Then what are the corresponding parts or corresponding factors of these 3? So z plus, here plus I means the first factor, that is z minus I, and minus I means z plus I, and minus 3 means z plus 3. So therefore now f of z becomes z divided by z plus I, z minus I, z plus 3. Means we have merged the 3 factors of the denominator with numerator. Now that becomes the new f of z. Means we are not going to find the value of the integral at those points which lie outside the circle. Instead of finding the value of the integral, we are going to merge those functions with the numerator. That will become the new f of z. So now f of z becomes z by z square plus 1 divided by z plus 3, right. So the given integral becomes integration over c f of z by z minus 3. So now this is equal to, here the value of the a is equal to what? 3, then it is 2 pi I f of 3 by using the Cauchy's integral formula. Since the power of z minus 3 is 1, then we have to use the Cauchy's integral formula, that is 2 pi I f of 3. Then this is equal to 2 pi I. F of z, we know that z by z square plus 1 into z plus 3, So therefore 3 divided by 3 square plus 1, that becomes 10, and z plus 3 becomes 6, right? Here z equal to 3, then 3 square plus 1, then 9 plus 1 becomes 10, then 3 plus 3 becomes 6. Now 3 ones are 3 twos are again 2 and 2 get cancelled. It is pi I divided by 10, which is the required value of the integral. See, so if you want to solve in detail, you then also will get the same answer, but here the extra work is partial fraction. Here you have to consider, here we have 4 factors, then a, b, c, d, those values you have to find, and after finding those 4 values, again you have to find the distance where the point lies outside of the circle and its value is 0 only. Means for the 3 points z1, z2 and z4, the value of the integral is 0. Then again you have to find the value of the integral at only at the one point, that is z3, which is equal to plus 3. So therefore instead of doing all that, just merge the factors in the denominator for which the points lies outside the circle. That is the easy work. So these are the examples on Cauchy's integral formula and Cauchy's integral formula for derivatives. So let us take the assignment questions on this topic. So these are the assignment questions. The first one is integration over c e power 2z divided by z minus 1 into z minus 2. C is mod z equal to 3. Here we have 2 terms in denominator, so use the partial fraction. Here 4 minus 3z divided by z into z minus 1 into z minus 2. Circle is mod z equal to 3. Then 1 minus 2z, z into z minus 2 into z minus 3, and here see circle is mod z equal to 3 by 2. Then z cube minus 2z plus 1. So here for these 3 problems, use the Cauchy's integral formula, because the power of each factor is 1. So whenever the power of the factor is 1, then use the Cauchy's integral formula. And here z minus I whole square, it is greater than 1, then use the Cauchy's integral formula for derivatives. And here 1 divided by z square plus 1 whole square. Here z square plus 4 can be written as z plus 2y, z minus 2I. Whole square is there, it means that whole square means squaring for each term. Then this is z plus I whole square, z minus 2I whole square. So first find the distance. Here the center of the circle is not origin, this is minus I. Then z0 becomes 0 comma minus 1, then z2, z1. Then afterwards find the distance z0, z1 and z0, z2. If the distance is greater than 2, then the point lies outside the circle, and if the value of the integral is value of the distance is less than 2, then the point inside the circle. And then 1 divided by z into z minus 1, partial fraction. Here z square plus z plus 1 divided by z minus 2 whole cube. So here you have to use the Cauchy's integral formula for derivatives. So solve these problems and upload the solution in the Google Classroom.